About to start. Okay, I'm going to hand you over to Chris Ward-Jones, who's going to be talking about the panel. We're going to be talking about sustainability, driving sustainable low-carbon Web3 technologies through the immersive work loads deployed in renewable. Yeah. What does that mean? Right, take my teeth out.
Two. Okay.
Is it that or this?
Sorry, that's mine.
Yeah. That might help.
Two.
Yeah, so we all had a little bit of a look at the title a while ago, and we tried to figure out what it meant ourselves. The reality of the situation is it's sustainability in the industry, where we are today, where we need to get to, and how we're going to get there. So I'll let the esteemed panel introduce themselves. I've got more microphones, so just...
Can anyone not hear me at the back? Oh, I've got, okay, no worries. Okay. My name's Simon Brady. I'm from Submer.
Pass it down. A little bit about what you do as well would help.
I'm Mathiesen. I'm from a company called GlobalConnect, who operates 17 data centers in the Nordics, and we have a immersion cooling service and a co-location service as the first in Europe.
Hi, Warren Barrie from Bulk Data Centers. We're a Nordic-centric data center operator focusing massively on sustainability.
I'm David Khonstamm from Leaf Cloud, and we're a carbon negative cloud provider.
I'm Matt Craggs from Deep Green. We're building edge data centers with a focus on heat recovery using both immersion and direct liquid cooling for that, to facilitate that.
Cool. Right. So the industry, data centers, largely perceived as being extremely large buildings that have a huge demand for power, suck up massive amounts of power, and very inefficiently as well. Or at least that's a perception maybe outside of this industry, and it might have been true, say, 20, 15, 10 years ago. So if we look at the larger builds that that exist in the industry today, there's sort of like double-digit megawatt facilities. What are we doing today that's different to what we were doing, say, 10 years ago? What makes the industry more sustainable now? What's happening in the space? What are we doing?
What's different? You asked a number of questions, but what are we doing different now than that we weren't doing 10 years ago? Nothing.
Yeah.
Nothing. We are still putting IT equipment in 19-inch racks and throwing 21 degrees cold air at it and paying even more energy to cool that off the back end. And whether I've got my Submer hat on or my previous Green Grid hat, whatever, we as an industry, from a physical infrastructure port, have not changed, and that's actually our biggest problem, is getting people to. I've given a presentation for years about putting blanking panels in racks. I still walk around data centers and still find people not putting blanking panels in racks. So, I want us as an industry to move to more sustainable, more immersed workloads. I would say that I work for an immersion business, but the reality is we have to get the industry to start doing the basics, as we've explained in ASHRAE TC 9.9 and all the other plethora of sustainable standards. If we could do that and deploy some of these new technologies, then we really win a watch. So that's what I would say from that.
It's a change in mindset, right?
It is. It is a change of mindset.
And people have invested huge amounts of money in air cooling and so on, and that infrastructure. So
but we, as an immersion business, we can all see that they can coexist, and air cooling's not going away. Mm-hmm. It's not going to disappear. We have to live in this hybrid environment for a long, long time. So systems have to work alongside, but the heat reuse piece, and these guys will attain to that more than we can, is going to be a huge part of that. We're just the enablers. We're just trying to get that message out there, educate the industry as to what can be done. These guys are living it on a day-to-day basis.
Yeah, absolutely. So on that day-to-day basis, people perceive data centers being built, great big buildings, and day one fitted out for a certain amount of power and cooling, etc. Is that right? Is that how data centers are built these days?
Yes and no. We do say that. First, I also want to talk a little about us not doing anything.
Mm-hmm.
I think the data centers follow the Keynote model quite neatly, where we're going into the technologies that we have, which is air-cooled, and we're trying to utilize as much as we can on that. We're seeing getting on district heating, as some are done, and we optimize putting AI into the Craggs units, and so we're doing as much as we can with the technology at hand. But as Keynote states, that if you want to really leap, you need to get as much out what you can, and then you take the leap afterwards. I think we're just at the tipping point of that leap where we're going into immersive cooling, where we actually say we can't get any more out of air-cooled as it is right now. Yet there's some bumps around the way. We can put in blinding pads. We can alter temperatures a little bit. But if we really want to do a leap in technology, we need to go elsewhere, which we would agree on. And back to the sizes of data centers. Yes and no. We get the hyperscalers. We get the big ones coming in building hundreds of megawatts elsewhere. But you also get the sense that all these telcos, including ourselves, is a place where we have like repeater sites, inline amplification sites, where you can fit 40 racks into. So now we're talking about those racks that have only been for telco, which means they've only been like DC. But it is a location. It has power into that location. It has the surroundings, and the people in the neighborhood has accepted that this is a box that sits there and the internet lives in there. So if you go into the edge, is that going to be the new edge where we actually start to transform these kind of things, these IL8s or repeater sites, into being active data centers where you have active equipment in, you'll have even large, maybe a tier 3 generator, or maybe you stick with the tier 1, but just having one. But that's in a place where you have a lot smaller, but a lot more once you want to get closer to the eyes.
Yeah. So now you start moving towards an edge type deployment, right?
Exactly, depending on what you define edge as.
Which has many definitions currently.
Exactly.
Let's be clear.
Yeah.
Okay, cool.
Do you want me to add to that?
Yeah, go on, add to that. How do you build data centers?
So we have a scale campus based in Khonstamm, southern tip of Norway, which, just to sort of quantify it, 3 square kilometers of land, up to 1 gigawatts worth of power, with 400 megawatts of power committed. And ours is very much run, or designed and developed on a modularity basis. So everything we do is incredibly modular, packaged units, assembled off-site, shipped onto site, and literally delivered in line with customer demand. So I think gone are the days of building these big buildings and leaving them unoccupied and waiting for customers to fill them up over time. The building blocks are much smaller, and it's much more in line with customer demand to the extent where we can control cost, we can obviously control the sustainable elements of it. And yeah, so that's what we're doing on a very big campus. We're not rolling out a big building and then trying to retrofit that. It's very much based on customer demand. But coming on to the sustainability side of things, and I'm just going to touch on what the guys have said before, but we are running high density workloads and still using air, but also water. Also direct liquid cooled. I think when you've got water as the backbone, closed loop chillers, free air cooling chillers as the backbone, or any water medium, it gives you a lot more flexibility inside of the actual facility. So we are deploying standard densities of 20 kilowatts a rack. The majority of our requirements at our large campus are between 40 and 60 kilowatt deployments. And they are using a combination of rear door heat exchangers, in-row coolers. So we're squeezing the pips out of the space that we've got there. And I think that's a key part of sustainability. It's not just about how you're sourcing the electrons, how you're consuming the electrons, what are you doing with the heat, and reusing that, but it's how are you using the space and how are you actually building the building blocks. So things like green steel and green concrete, for example, or other mediums of building. They're wood structures these days that are widely being adopted.
Yeah, so like BREEAM credentials, etc. So, okay, cool.
I think that the market is finally realizing that the heat is not part of the issue; it's part of the solution. And in a way, you still hear a lot of people talking about using green energy and offsetting. But if you put a space heater in a field and give it green energy, that doesn't make it a green space heater. It just doesn't work like that. And I think the big cloud giants are very responsible for a lot of this sort of almost misinformation. And just as Warren said, doing these small steps is very important, because when you build small data centers, you build them full in one go. And you can use existing locations, and then you start actually reducing costs to where you don't have to be hyperscale to compete in costs. And that I think the market is starting to move in that direction, starting to realize that. But it's going slowly, and I think the uptake could be a bit better.
Yeah, I mean, I agree entirely with. I think we're in an echo chamber here with sort of from heat reuse in the Nordics to what we're doing ourselves. I think, yeah, using smaller deployments, modularity, and particularly retrofitting the built environment is going to be key moving forwards for this. Because I think what we're seeing is not only massive savings from a host perspective, which we use as to be frank, to not pay rent. Like, that's a tangible, hits our bottom line straight away. But on top of that, we're making massive savings by not having to create any built environment, using existing systems, existing processes, and really minimising the amount of tech we're needing to deploy at all. And then on top of it, looking at how the data center industry as a whole integrates more within society. I think if we sort of back on envelope calculation we did a few weeks ago, but if we took every single watt of deployed power across the data centers across Europe, we still wouldn't get to within 15% of the heat load required to heat the buildings within our residential estate. Yeah. So if we think about it in terms of finding a way not only to use our energy more efficiently, but focus on our net impact on the environment rather than our absolute, I think that's going to be key moving forwards.
Yeah, no, quite agree. And you guys, so, you know, David, Matt, both, you guys are pretty much topping out of your energy reuse right now, aren't you? I mean, you've pretty impressive statistics.
Our locations use more heat than we can give to them.
Yeah. So you literally repurpose all your heat.
Yeah. Yeah, 100%. The unique thing is we still use Datacenter for the core of the compute, storage and the controllers. So that's the part we can reuse. Mm-hmm. And we actually have one site where we reuse more heat than we give, because the location itself has a lot of heat to give as well. And by using heat pumps, we can actually deliver that as well.
Okay. And is that something that's easy to achieve without immersion cooling? There's a lot of talk of immersion cooling here, but
Yeah, so we don't use immersion cooling at the moment, purely because of secondhand hardware.
Yeah.
We have dabbled in immersion cooling, also developed our own at some point, and stepped back from that and really tried to focus on the software side and getting the cloud market as a whole to move to sustainable alternatives.
Yeah. That's a really interesting point, because you guys are repurposing heat from air, right? And
yeah.
There's a lot of talk around immersion cooling, but it's possible with both, isn't it?
Yes. But the unique thing is, in a data center, you're far away from the point where the heat needs to be reused. It needs to be high temperature. Once you're at the location where it is used, you can start doing stuff like floor heating. That's basically 30°C water. Mm-hmm. We give 30°C air, 40°C air. So using a general off-the-shelf heat pump, you can do basically the same.
Yeah, I'd say what immersion is doing for us is making it much more scalable. Mm-hmm. By getting the heat energy out in a reusable format. It's meaning that our installations aren't requiring any specific skills to maintain from a heat recovery perspective. It's all pipe work that is familiar to anyone who's got a basic industrial plumbing certificate. So I think that's really, it's making it a much simpler process to deploy, in that we can find local engineers and maintain those systems very easily. Yeah. And it's not something that is a surprise to anyone. We're really having to innovate on anything around heat exchangers, pumps. Everything is off the shelf, readily available, and that's really sped up our speed to deployment, to be honest.
Okay. You want to chip in?
Yeah, I want to chip in on the reuse of heat, because we operate in the Nordics, at the forefront of that. On that area, on that journey to reuse everything. And what we do in our data centers, especially the one where we have immersion set in, we run our immersion on, partly we can do it on a free cooling setup, but we are the only ones who have a redundant CDU in our, I don't know if you built that yet, but it has a redundant CDU in it, which means that we can also run it on our chilled water system. Mm-hmm. And that chilled water system, since all our data centers are, in our terminology, near edge, so we are kind of close to urban areas, we had the possibility to put also district heating systems that is in the town. But what we see in Denmark, or especially in Denmark, is there's a lot of talk about who owns what in that system, and that whole micro dome of temperatures going up, temperatures going down, who has the heat pump, who gets paid for what, who gets what kind of revenue for it. essentially what we did in our areas is that we said that we just want to get rid of the heat. And we don't want to charge anybody for it, but that also means that we do not want to buy and operate any heat exchangers to get up to the level where you want to be this 70 degrees, whatever you want to do. Yeah. So we made the deals with the district heating companies saying that we have a tap out here on our chill water system. Yeah. All the heat you can drain from that's yours to take, but we just want a exit button. So if you have a leak, we can push the button, valve shut off, and we'll just run it through our chillers or dry coolers, whatever we have. But as for my knowledge, we're the only ones to give it away currently. People are still investing in their own heat pumps.
We do too.
Yeah, we do. Yeah.
I'm sorry, in the Nordics.
Yeah. Otherwise, we'd have to deal with metering.
It would sound better if I was the only one.
I think that's where the challenge is, in that when we have these conversations, it's not about every single data center operator. It doesn't matter who you are, would gladly give away that energy, that waste as nothing. Some of the barriers that we come across, it's interesting about Denmark. I used to work for ABC, had the factory in just outside of Billund. So there we had a 4.5 megawatt steam generator to do heat load testing for UPSs. And there was a local swimming pool, and we said, you can have our heat for nothing. We run our systems 24/7 a day, and the local government said, great, fantastic, you're now an energy provider, you will be taxed at this. Okay, so it was actually cheaper for us as a business to blow that away as nothing than give it away for free. So whilst as an industry, we have to get, we are completely willing to do that. We have to get around some of these barriers that are put in place by legislation, by local government, and for the society as a whole to understand that and come on board with us. So we need to align. But also to come back to the availability question, in that, again, it's great if you design a facility and you can reuse 100% of that heat. What happens on a really, really hot day when nobody wants the heat? Yeah. We live in a high availability society. So again, a lot of clients, whilst they want to have the ability to, if they're in the right location and there is someone that can take the heat, there's always going to be that situation of, well, there's a day when they're not going to need it or all of it. So you have to have the ability to reject that heat to keep the workload up. So that then comes down into, well, there's a cost to giving away that heat for free, and who bears that cost? And that's probably one of the biggest, not barriers, but the question marks that come at who funds that, who pays for that, whose responsibility is that to do that? And there isn't enough joined up conversations within us as an industry and with local, national governments and industry bodies.
Yeah, and I think just to add to that, because that's a good point. We're talking about district heating now, but there are other use cases for heat: hydroponic farming, aquaponic farming, drying of wood chips. And these are the things that we are starting to build into our campus approach, where we're actually attracting industries in, and they are setting up business, and we're creating a circular economy with the heat that comes from the data center. We happen to be too far from any residential or business area that we can offload the heat to, and it's not commercially viable for us to do that either. So creating these alternative industries where the heat isn't subject to climatic conditions is what we are doing.
Commenting to things where it costs us to build, we are actually saving a bit of money on free cooling units once we have added to district heating, because in the days or weeks or months or whatever it is where you will normally use free cooling, or where you can't use free cooling, those will be the same days where you can't get district heating, give you heatways to district heating as well. So that actually cancels each other out. So the more investment that we had on putting a little bit more valves in it was actually cancelled out by the saving, where we didn't have to buy these large free coolers because it will be running at the same time.
I think we're talking about here already existing campuses with already existing businesses. I think by being sort of new build in what we're doing, I think the way we're approaching it is looking at existing heat load data and profiling site in an entirely different way. So we look at available power, we look at all the grid capacity, but we also, as part of that limitation, look at their own heat profiles and become part of a portfolio solution rather than as a one-off. So I'll give you an example of a district heating system we're looking at doing over in East London, and where essentially the data centre is going to provide their base load. So if we look at their load profile throughout the year, including on the hottest days, we're existing there, or setting a target of venting a very little amount, less than 10% of the year or less than 5%. My current sites are at less than 1%, and profiling those sites that way, and using that in combination with giving the heat away, means that to an extent, we're able to save on the capex from the cooling side because we don't need to install as many coolers. But on top of that, it's a much cheaper running cost while we're going. So if you're looking at us kind of a holistic view, the savings are still coming back, and by giving that heat away as well, it's given us a huge access to sites. So we've got 4,000 sites with rates of over 200 kilowatts in the UK alone have signed up with us in the last 6 months.
Yeah, and I think data center operators are adopting technologies and sustainable practices as much as they can. But the one problem we do have, and it's something that no one really addresses, is we're not in control of what our customers put in to the data center. So what hardware are they putting in? How sustainable is that hardware? We've got no control over that. And I mean, we're seeing an emerging market now for second-hand equipment, which I think is being adopted widely, and I think is a great idea. The carbon footprint for that's already been written off. But we're all selling to bigger and smaller customers. They're all putting in the latest GPUs and the latest CPUs. Presumably they are sustainable, but to what degree? And we're just not in control of that.
Yeah, that's a good point, especially the recycled hardware point of view, because that's your scope 3 dealt with, right?
I think what's the main thing that's missing in all of this discussion is we're all talking about it from an infrastructure side, when the real emitters are the guys in the other event here, the AI summit. Those guys putting the big workloads, they have to choose for a sustainable provider or a sustainable colo, and they are still very cost driven. And they can be, and sustainable in our way can also be more cost effective. But there does need to be some alternative way to push these clients into a sustainable alternative. And I really think that either taxing the big cloud providers in some way, shape or form. That's the only way to go, because
yeah, absolutely. So you're probably looking at like regulatory change, etc. as well.
Yeah.
Right.
Yeah, I think there's also a lot more onus should be placed on the manufacturers of the equipment, and it's something that we're seeing change right now in terms of multiple providers bringing immersion-ready servers straight to market, fully warranted. That's made a massive difference to the decisions they can make, and that's in the last couple of months. If at all, whereas 6 months ago or even a year ago we were looking at having to strip everything down, literally replace every capacitor on a circuit board because we couldn't get traceability on the components. Now it's coming to market and you can start making those decisions.
Yeah, we're making huge strides in that. As much as we are a manufacturer, we make tanks and supply fluid and what have you. A huge part of our R&D effort is to make sure that the Intels, the Nvidias of this world, the Lenovos, are on board with that, and they're offering both the air-cooled SKUs and the other SKUs. But again, it comes down to, and whether I was at the Green Grid, and we all both love and hate the PUE metric. But we've all talked about PUE, and we're trying to get from the average of 1.7 or what that number is, and we want 1.5 and a 1.3, and the hyperscalers talking about 1.1. Everyone forgets 1. Yeah. One's the load. Yeah. We have to reduce that number as much as the mechanical side of things. You talk about the space heater in a field. You could put a rack in a field, and it's with no air conditioning, and that's a PUE of 1. But is it a sustainable item? Is it a sustainable service? So we have to look at that, and then you could, and again, he's not here. We were missing Mr. Bitterlin, where they'd say, how do we then reduce that consumption? At what point do we say to society, well, we're only building to customer demand. We're only building data centers to support the Twitters and the Facebooks and the TikToks. At what point do we not hold on to photographs for 10 years and those kind of questions? So there's a demand side and a societal question as much as us as operators and manufacturers to reduce our consumption.
And the interesting thing is, like you say, that a lot of those manufacturers are now actually shifting towards supporting a standard, immersion cooled SKU. They're being more supportive, right? They're actually doing something.
Absolutely, and they recognise that there's a benefit for that as well. And from a circularity point of view, the equipment tends to last longer if it's immersed and it's operated that way. So
exactly
we 100% agree on the reusing of equipment, but in 5 years' time, all our equipment will be immersible. So we're very much playing the long game on that regard.
Yeah, and we've been doing work with some of those hardware manufacturers ourselves around supporting and building standard SKUs for them. And I would say that there's been a huge change in the last 6 months in appetite to embrace that sort of technology, right?
I mean, the other thing is it's changing the want.
Yes.
So I was at one of our server partners the other day. Simon's very familiar with them, but they had some servers there from their HPC perspective. The fans are drawing 300 watts. So if we're changing our view from a PUE perspective to a power intensity of compute, so looking at the actual performance load we can get per watt, that's going to make a massive difference in the way we measure ourselves as an industry.
It was one of the meetings I had with a client yesterday. We were going through the pros and cons of immersion, and we were looking at installing immersion into an existing data center with a chilled water loop. Okay, so not a design from day one. So we were going through things, and I said, but I will make you aware your PUE will increase. And they looked at me funny. He says, because you take a 1,000-watt server that's now only an 800 or a 700-watt server, so your one will decrease. Your point stays the same, so actually your PUE increases. And the look of incredulation on their faces. Now, thankfully, we're away from where we used to be, in that people were bonused on the reduction of PUE, which was fine. Just go out and put some heat loads in your data center. Yeah. But they're still trying to manage that on that number. So we, again, as an industry, you just got to be aware of total kilowatts consumed.
Yeah, and like PUE is just a really bad metric, isn't it? It depends on how you interpret it.
No, it's not a bad metric. It's been used and abused.
Yeah,
it's been used and abused. It's been used as a marketing tool. I'm a big advocate of it. It's a great tool for understanding where you and your data center are today and where it needs to be tomorrow. Not as my data center's better than your data center.
Precisely, and so long as everybody interprets it in the same way.
Well, it's an ISO standard. Everyone should measure it the same, but they don't.
But
anyway,
don't.
That's another conversation for another day. Yeah. But I agree. It's not the perfect tool, but it's what we have, and so it shouldn't be it shouldn't be maligned that badly.
Okay, we've only got a few minutes left, so just to flip the conversation slightly on its head, there's if we look at the total energy consumption of the industry, right? It's pushing the photons around, right? The network, that's the real biggie, right? And addressing the power consumption and the sustainability of the network. I mean, how do we do that? So there's a lot of talk here about immersion cooling. Optics are notoriously hard to immerse. So as the digital universe grows, you get this sprawl. We're now referring to edge, etc., and so on, and we get more and more edge locations. Does decentralization have a piece to play in positioning the data nearer to the end user?
Yes.
Okay.
Definitely.
Tell them why.
Well, so we're speaking with one of the major content distributors in the UK, and they are spending as much energy sending their data around the UK as they are in storing and running their entire computer estate.
Which is something that a lot of people just don't realise, right?
Yeah, if you think about that's changed the target from 3% to 6% of global energy consumption just in that way. So if we are looking at sustainable ways of deploying even to things as basic as cache servers nearer to where the population are consuming it, and that's something that isn't just aligned from a data perspective, it's aligned from the types of services we're going to need to consume in the next 5 years. It's a whole direction of travel that we can get much more efficient just by thinking a bit more outside of the box, I think, or the traditional method of deployment in the way we think about resiliency from those networks and the way that they're deploying, and still using the large data centers as that kind of that callback, that sort of single version of the truth that you can then lean back on and fall back on, but deploy something at the edge that is cutting energy consumption that way.
The optic piece is a good question. That there are ways and means of doing that, but as I said earlier, the air world is not going away, and I think the hybrid environment is going to be where we're looking at. But what I will say is that where we have equipment in the air world. Actually, interesting enough, networking equipment tends to live in that higher ambient temperature just because of the telco space it's sat in. But we need to be encouraging, and I still see it in these comms data centers, and we all know the big names and the players. You walk in there, and they're still running air conditioning systems at 21 degrees C, 55% relative humidity, 24/7, and a lot of this kit in there would work in the desert if you just left it there. So again, understanding about what really does need to be mechanically cooled and not mechanically cooled, and when is it beneficial to cool or heat reject. So that's what
you don't actually need submersion to reuse heat. You can use heat pumps or other systems.
Right.
The only thing that matters is where do you put it. But do you put it where the waste heat can be utilized or not? And once that market starts understanding the value of the heat and actually reusing those locations, then it'll change. But right now, yeah.
Cool. Any closing comments? Good.
As Arnie said, just do it.
Yeah. Any questions?
I've got one. Yeah.
You would have, wouldn't you? Go on.
Well, that's why they pay me the big bucks.
Yeah.
Question is, obviously I work for an immersion provider, but the question to the panel is, who do you see driving this market forward? Is it us as the manufacturers? Is it the end users? Or is it the hardware and silicon manufacturers?
I'd say the hardware and silicon.
That's what I think.
I think it's the end users.
I'll go with it. So I don't want you have mine. So. No, I would go with the end users because at the end of the day, we strive to be a better planet, doing everything greener. And the end users are putting demand on all the suppliers in every aspect of life. You need to do better. And one of the things where you can need, if we're saying that they're not willing to give up internet, I don't think anybody's willing to give up that. Then we need to do better, to provide it better. And the ones who are better at it, they will get the bucks. At the end, I think the rest will follow. I think that's the motives that we need to go for. We need to demand, customers need to demand from us that we need to be better.
There's an education piece there as well. There was that show that was on TV just recently. But also, we need to be out there telling this younger generation, the swipe generation, the TikTok generation, what impact is it that you do when you have your phone and you stream for 5-10 minutes? Not to say they should or they shouldn't do it, but knowledge. We know if you buy a car that's efficient to a certain level, then you can make a conscious decision to go from gas to EV, or you buy a more efficient car. Nobody has that with regards to an efficient phone, an efficient website, etc., etc. So
lack of awareness.
The education piece, I think, is very much at the top.
Yeah, can someone tell NVIDIA that though?
Well,
Yeah.
If they paid,
we're trying.
if they paid for the bit or byte they used, I think it'd be a different story. You wouldn't.
It would, and again, Ian said a long time ago, if you sat a child down and said on their phone, for every photograph you take, you have to pay 10p to store it, they take a lot less photographs. It's about carrot and stick and education, and that sits very much at the top of the tree.
Has anybody got a very, very quick question? We are actually at time, but have we got one? No?
More conversations like this to be at the bar this evening.
Absolutely. They're all available at the bar, all to buy you a drink, I hear.
Free bar.
Excellent. Okay. I'd like to thank the panel very much. Thank you.
Thank you.